Yeah, in the last video, we skipped this one. Probably will change the form of the questions. So we want to look at this one, integral of 1 minus 4 minus 3x power 5. Okay, dx. So this video is a continuations of is a continuation of the previous video. So here, this will be equal to integral of 4 minus 3x minus 5 dx. Remove this 1 over, that's minus 5. And this will be equal to 4 minus 3x minus 5, okay, minus 5, then plus 1, so which will be minus 4, okay, then you divide by the attachment to that constant, which will be equal to what? Times 1 over minus 3, okay, then plus c. So this will be equal to this one times this one, that's 12. So that will be equal to 1 over 12 into brackets 4 minus 3x power minus 4 plus c. So if you want to go for that, I want to remove this minus. So that will be equal to 1 over 12 into bracket 4 minus 3x over 4 plus c. Okay. Another question we want to look into in this case is, yeah, we want to look at these two questions. The first one, integral of dx over 4x s squared plus 4x plus 3. So what we can do there is for us to express this one, this denominator, express it as a sum of square by using completing the square method. Okay, so which will be equal to, you take one of these, then plus half of this one, uh, half of coefficient of x, which is 2, then square it, and whatever you are adding, take it also outside. Okay, then plus what? Plus 3. Okay, and that's x plus 2 square, and this is 4 plus 3. That's what? Minus 1. Okay, so we're now having now integral of dx all over x plus 2 square minus 1. Is it minus 1? Yeah. Sorry, this is 13. You can see this is 13. So plus 13, plus 13. So plus 13. So this will be equal to 9. So plus 9. Okay? So plus 9. Yeah, plus 9. So from the table, this will be equal to arctan x plus 2 over 3. And then you divide by what? By a, 1 over 3. Your a is 3. Okay? So and then plus c. Plus c. So that's that on that question. I think one of our video on quadratic, I've explained how to use completing the square method to solve a quadratic expression. And what we did here in this expression is for us to, you take one of these, okay? Then the sign here is addition. You take that addition, then you add half of the coefficient of x, which is 2. So whatever you are adding, take it outside also. Subtract it, minus, minus what? 2 squared. I added plus 2 here. I need to take it out. Okay, and then plus 13 you have here. So then you do that, you have this. Number 2, integral of dx over 12 minus 9x squared. This is also quadratic, so I need to also turn it to sum of square. But let's see how we can do that. Can we take this minus 9 outside? Take that minus 9 outside, so we have s squared minus 12 over 9. Okay? Yeah. This is 12x. This is 12x. This is 12x. Okay? So if you take the x out, that will be this. Okay? This is 12x. So this will be equal to minus 9 into bracket s squared. 3 here. 3, 12. That's 3. 3, 12 is 4. That's 4. 3, 9. That's 3. Okay? So we have this. That's 4x over 3. So this will be equal to, what can we do now? So that's what we've got. So the next thing to do, minus 9, okay, especially as a sum of square. So take one of these. Then this is you're adding half of this. Half of this is what? 2 over, I think 2 over 4 over 3 divided by 2. This is 4 over 3 times 1 over 2. So that's a 4, that's a 2 here, 1, 2 here, that's 2 over 3. That's 2 over 3 square. Then minus whatever you are adding here, take it outside. 2 over 3 square. Okay, 2 over 3 square. 2 over 3 square. Then you close your brackets. Close your brackets. Okay, and that will be equal to minus 9 into brackets. Don't forget that this one is already closed here, so you can solve it. This with 3 times this, 3x minus 2 over 3 all square, then minus this one square, that's 4 over 9. Okay, so that's what we've got there, 4 over 9. 4 over 9. I think this minus 9 can come in, then we can have minus 9 into brackets, 3x minus 2 over 3. Okay, square, and then minus times minus, that's plus, that will become 4. So that is established. That will become 4. We can also take this one out, which is equal to minus 9. This 3 at the bottom, we can take it out, which will be what? Times 1 over 3 square into bracket 3x minus 2 square plus 4. So this will cancel out. This will cancel out. So I have what? I have minus into bracket 3x minus 2 square plus 4. So that's the expression. Now, this one, that expression, this one, square root of 12x minus 9x squared, okay, will now be equal to integral of dx all over square root. We got 4 minus 3x minus 2 all square. Okay, so that's what we've got now. That's what we've got in now. So, and don't forget your identity. Our identity that says that dx square root a squared minus s squared is equal to arc sine x over a plus c. So in this case now, this will be equal to what? In that case, that will be equal to arc sine. What do we have there? 3x minus 2 over what? Over 2. Okay, then you divide by what? Attachment of that variable, 1 over 3 plus c. So, and that's that on that question. That's that on that question. Very interesting question. So I'm going to recap what I did on the completing the square method. It's very simple. What we did is, the question is integral of dx over square root of what? 12x minus 9x squared. So let's take it outside. Once we take it outside, we can take this minus 9 outside so that we can have x squared minus 12x over 9. Okay, then you can slash this one. 3 goes here, that's 4 over 3. Okay, then the next thing to do is to express this expression as a sum of square by completing the square method. Okay, you take one of these, okay, you want to turn into perfect square. Then you take the half of 4 over 3, which is what? 2 over 3. Then you close your bracket square. Okay, and then minus whatever you had, you've added 2 over 3 here, you take it outside, and that's 2 over 3 square. Then you close your brackets, because this minus 9 affect everything. Okay, then express 2 over 3 as what? That's 4 over 9. Okay, then allow the 9 to go in. If 9 goes in, it's going to affect this one mean power 2, numerator, power 2, denominator. So this will be 9. So this one will cancel out. We have the minus of this expression. And then this one also minus 9 times this one. That will be plus 4. And that's what we have done there. And finally, we arrive at this. Okay. And what we are trying to bring out here is that the form does not change compared to what you have here. Look at here. Okay. It will not change. Your x there is what? 3x minus 2. Okay? And then your a here, your a here is 2. 2 squared. Okay? So you give it the same form, the same answer. But you have to check the variable. Is the variable being multiplied by something? If it's yes, then you have to divide your answer by that variable. So that's over 3. So that's that on that question. Then the next one is to go to log 5 now. The fifth law. That's be the next video. The next video, the fifth law is saying is that if you check this one now, check the derivative of this. The derivative of this is what? Derivative of 4 is 4, x to the power 4, that's 4x3 minus 1. Okay? You should realize that the numerator is equal to what? The derivative of what? Of the denominator. The numerator is equal to what? The derivative of what? Of the denominator. So in that case now, it's going to be what? It's going to be ln or log. It's going to be ln of the denominator. So that will be equal to 1 ln of what? x4 minus x plus 2. So, and then plus what? Plus c. But sometimes it's not always direct. You have to do some adjustments, okay, to make it equal. So we'll look at those questions later. Another question. 3x squared all over s cubed plus 1 dx. Okay? This one will be equal to the derivative of denominator is equal to the numerator. The numerator is equal to what? The derivative of denominator. So in that case, it's going to be ln or log to base e of that of the denominator. So plus c. So that's that. ln and log to base e, they are the same thing. Okay? Then exception to that rule is this. Look at this question. Look at this question. Yeah, look at this question. The derivative of the denominator, ddx of the denominator is 2x. The derivative of the denominator is s of this 2x plus 5. The derivative is 2x plus 2. Okay? But here, almost similar. This is x plus 2. So what we are going to do now, to force this numerator to be equal to the what? The derivative of what? The denominator. We are going to introduce 2 to the numerator. Okay, if you introduce 2 plus 2x plus 5. If you introduce 2, then we cancel that 2 outside. So that's what we're going to do here. So it's not every time that you have the derivative of the you have the numerator being equal to what? The derivative of what? Of the denominator. Sometimes you have to make some adjustment. You have to manipulate so that it will be equal. Okay. So, and whatever you bring in, you have to cancel it out. Whatever manipulation you do, you have to cancel it out outside. Then in this case now, if we expand this one to be 2x plus 2, which is equal to what? The derivative of what? Of the denominator. And that will be equal to what? Half ln or log to base e of the denominator plus c. So that's that on the 5 essential rules for integrations. I think the next thing to do now is to look at practice questions so that we can apply all the 5 rules on those questions. Okay, join the next video for practice questions. Please subscribe to the channel. Thank you for doing that.